We're now ready for phase 2 of our shortest route assignment. And so I have updated the PDF, and not much has changed at the beginning here. It still talks about the background, the greedy heuristics, and there's a new heuristic or idea for an algorithm, and it is the smallest increase in path length heuristic. So you're doing the nearest neighbor. That's one main that is running, and I'll talk about how those are set up on my website. But then here's the second one. So I want to talk about that a little bit using some points, and then showing you that that's running. And again, now you don't only have this insert at nearest that has main in it that will run that first nearest neighbor heuristic, but you have another file that I have on my website you can pick up. They look almost identical, these two, but this one is going to run the method where you'll check the smallest increase in path. And then I've added to these outputs. So you still have the insert at nearest. So these are still showing these three possibilities with the text files, but now you're also running it with the smallest increase. And so you're going to get those images. And you'll typically see that if you use this new heuristic, you're going to get a slightly better path. It still might not be optimal, but it's going to be better. So let me talk to you about what this technique, what this heuristic does. So just as I did for the nearest neighbor, I'm going to choose some random points, and then we're going to try to apply the algorithm. So we'll just start with some random points. 7, 8, 9. Okay, so about 9 of them. And let's number them. So there's, whoops, let me do that. So let's number them. So here's 1, here's maybe 2. Let's call this one 3. And then how about that 4? And then here's 5 and 6 and 7 and 8 and 9. Okay, so we've got these points. You can imagine that these are in the text file. So the 1 is that first point that you were getting in the text file. Then you're going to pick up the second one from the text file, the third one. So imagine you're reading from the text file. And so we want to draw, at least think about drawing lines here. And so with picking up the first 2 points, you're not going to really have any choice, right? You're going to pick up the first point, and that'll be part of your path, and then pick up the second point, and that'll be part of your path. So you start there from 1 to 2. Okay, then when you pick up the third point from the text file, then you're going to start making some decisions. And so you'll compare if you put 3, the third point, in between the first and the second, or if you put it after the second. And here you have to think about the full circuit, right, going back. Which path is going to be the shortest? Now, in this case, you get a triangle. You get the same triangle either way, so it doesn't really matter. But the algorithm says that if there's a tie, then it goes to the first position. So in this particular case, you're comparing it to 1 and 2. I'm going to erase this line, and then we're going to draw between those two and then these two, because there was a tie, right? You create that triangle either way, whether you are going from 1 to 2 to 3 or 1 to 3 to 2 and back. It's the same triangle. And you do have to think of, even though I'm not drawing in, you got to think of that last line that is coming back, because this traveling salesman problem, you're always doing the full circuit. Okay, now we get the fourth point, and so we want to see now, is it between 1 and 3? Do we want to break that line and go 1, 4, 3, 2? Do we want to go 1, 3, 4, 2? So we would break the second line, or is it the last line? And in this case, it looks like you're going to get the shortest path if you think of that last line that is kind of imaginary in there, and we go 2 to 4 and then back. So that's what we'll do to minimize the increase, right? It's the smallest increase in the length. So we'll save that. All right, now we pick up the fifth, and again, we look at the collection we have so far. So should we break this first line and go 1 to 5 to 3? Or should we break this line from 3 to 2 and go from 1, 3, 5 to 2? Should we break the last line that you see and go from 2 to 5 and 5 to 4? Or should you go 4 to 5 and then to the end? Well, in this case, it looks pretty obvious that you want to reconnect so that 2 is connected to 5 and 5 is connected to 4. And again, think of that last line, imaginary line that's going from 4 to 1. Okay, so far so good. Then we get to the 6th point, and this one again looks pretty obvious, so you're not going to want to break the first line. You want to break the second line. That's the one that's going to increase the overall distance covered the least. And so we delete that, draw new lines. Okay, got 3 more to check. Okay, so for 7, we check, should we go from 1 to 7 to 3? Would that increase the distance less? Or maybe the 3 to 7 to 6? Or 6 to 7 to 2? Or 2 to 7 to 5? Or 5 to 7 to 4? Well, it looks like in this case, the imaginary line from 4 back to 1, that's the one that we are going to want to replace. Increase the distance the least. Okay, now 8, that's maybe a little trickier. So if I don't go from 1 to 3, but go from 1, 8 to 3, that's a possibility. Or maybe break the second line and go 3, 8, 6. It looks like maybe this third choice is the best. We go 6, 8, 2. Yeah, I think that's the best one. So my math could be off. I'm just eyeballing it, but I think the best choice here is to erase that. And then we're going to draw a line from 6 to 8. And then from 8 to 2. Okay, so far so good. All right, last point to pick up. So would it be better to, erase the 1 to 3 and go 1, 9, 3, or erase the 3 to 6 and go 3, 9, 6, and you're trying to find what is going to increase the overall route length the least. And it looks like this one's relatively obvious too. It's the 2 and the 5 that we're going to want to erase. So we'll do that. And then we will draw 2 to 9, 9 to 5. And then maybe the last, this is kind of imaginary from 7 to 1, but maybe not a bad idea to draw it in here. So maybe in a different color. So you also have to think of that. That is part of the overall route length. All right, so let me show you the running versions here. So here are going to be the final versions. And I have, in the PDF, we do have the final result, but this will actually show you it running as it's creating it. And just a reminder that you want to make sure, oops, that went really fast, but you want to make sure that you don't show the animation in your end result. I would suggest that you show an animation you draw as you go as you're trying to debug, but not for your final version. Okay, so this one might be able to see a little bit better. You can see it being built as we go. And this heuristic does typically give you a better result than if you are using the nearest neighbor heuristic. So these paths are going to be a little shorter. This one has 1,000 points, so it takes a while for it to run. But you can see one characteristic of the shortest path is that typically they're not going to cross one another. The paths are not going to cross one another. You'll get a better, you see this little region that we have up here, it would be better if they didn't cross. You could actually make it a little bit less. And most of the pathways here are not crossing, but it's still not optimal because I do see some places where it is crossing over itself, which would indicate it's not optimal. But still much better than using the nearest neighbor algorithm. So you want to keep working on that. Again, not much difference in the PDF that I have uploaded, the new PDF, but there's a new file with main in it, and you're going to apply this new heuristic and just keep plugging away at it. And this whole thing will probably be due on Friday, but I'll have that up on my due date. I'll include it on my website next week at some point. All right, thanks. Happy coding.